So section 1.7 talks about inequalities. So inequalities are very similar to equations and how we solve them, okay? So I'm going to show you how we can solve the inequality. We'll write our answer using interval notation, and we're actually also going to graph these on a number line, okay? So graph on the number line. Okay, so we want to solve the inequality. Like I said, we're going to solve it almost identical to the way we would solve an equation. So if I was trying to solve this like if I was solving an equation, I'm going to isolate the x, right? I'm going to get the x by itself. So I'm first going to minus 8 on both sides. Okay, so those 8's will cancel. Then I end up with a negative 2x is less than or equal to 16 minus 8 is still 8. And then my last step here is I'm going to divide everything by the number in front of the x, and the number in front of my x in this case is a negative 2. So 8 divided by negative 2 is negative 4. Now I'm going to show you something here. This inequality right now is less than or equal to, it's pointing to the left. Because we divided by a negative 2, my inequality sign, my friends, is going to reverse, okay? And I'm going to explain to you why it's going to reverse. So let me show you over here on the side. Let me get this going here. Okay. Why does my inequality sign need to flip? Okay. So suppose I had, I don't know, let's say the number negative 2 and the number 5 here. We would say that negative 2 is smaller, less than 5, right? Less than, we could even say it's less than or equal to. But now suppose we changed the signs and this became a positive 2 and that became a negative 5. I would now have to do this because the number positive 2 is going to be bigger than or equal to negative 5, right? So when I'm dividing by a negative or multiplying by a negative in this case, either way, our inequality sign is going to reverse. Okay, so there's something first that we call the solution set, okay? The solution set's going to look like this. It's going to be a little squiggly line, like a little squiggly brace, X. This little line here just means such that, and then all I'm going to do is kind of copy and paste. It's going to say X is bigger than or equal to negative 4, okay? Now, when we do the graph, okay, so think about it, I'm going to draw a number line. Okay? So the only number that I'm really concerned about putting on my number line is the number negative 4. Okay. And sometimes we use a circle or sometimes we use a bracket. We'll see in a minute. And because I have the equal to, I'm going to fill that circle in. Okay. And now I'm looking for numbers that are bigger than negative 4. Well, if they're bigger, they're going to be to the right. Okay. Now, guys, I want you to think about my number line. If I go all the way to the right, eventually we approach the idea of infinity. But if I would have gone all the way to the left, I would have had negative infinity. Now, I always do this on my number line because the next part is going to say, how do we write this in interval form? Interval form, once I have my picture right here, it's going to be easy for me to write the interval form. I'm going to start at the number 4. Negative 4, I'm sorry. I'm going to go all the way till we get to infinity. Because that 4 was circled in, I'm going to use a bracket. The bracket means I'm including the number, so I'm including the number negative 4. Now, I can never really include infinity because infinity is more of a concept, right? It keeps going on and on and on and on forever, right? So if you said, well, can I include infinity? That would mean that you found the biggest number. But whatever you thought the biggest number was, we could always say, well, let's add 1 to it. Okay, well, that's the biggest number. So we could keep kind of going on and on forever. So guys, one thing I want to mention on your number line, and I'm going to draw my number line again up here just for illustration purposes, okay? And here's my number negative 4. If you notice, I used a little circle and I filled it in. Sometimes they'll put the bracket and then they'll do this number. And if you notice, look at my bracket here. It's the same bracket I got right there, right? Okay, so let's try the next problem. We're going to go about doing it the same way, okay? So remember, I'm trying to get my x by itself. So I'm going to take this x, I'm going to subtract it on both sides. Now I'm going to get a negative 3x is less, oops, forgot about my minus 2. Minus 2 is less than or equal to 1. Then let's plus 2 on both sides. Negative 3x is less than or equal to 3. Then I'm going to divide again by a negative 3. And this is going to give me x is bigger than or equal to, remember, my inequality sign changed. 3 divided by negative 3, negative 1. Okay. Solution set x so that x is bigger than negative 1. Okay. Let me draw my number line. Remember, guys, over here I'm going to put a negative infinity, and over here I'm going to put an infinity. I'm going to go to my number negative 1 right there, circle it, fill it in, and then I'm going to shade this way. And so now, what is my interval form going to look like? My interval form, or sometimes they call it interval notation, okay? It's going to look like this. Negative 1 all the way to infinity. Okay. All righty. Next problem we got here. Okay. First thing I notice, I got a fraction. And on the bottom, we have a negative 3. So I'm going to multiply everything here by the number negative 3. So on this side here, let's see, negative 3 times 5 is a minus 15. Negative 3 times a 2x is a minus 6x. Since I'm multiplying by a negative, that guy right there is going to change. Now, one thing I want you to notice, this negative 3 and this negative 3, guys, they're actually just going to cancel out. So I'm just going to be left with 4x plus 7. Okay. Now, let's go ahead and add 6x to both sides. And let's see, that's going to give me 10x plus 7 is bigger than or equal to a minus 15. I'm going to go ahead and minus 7 on both sides. And let's see, that's going to give me a 10x is bigger than or equal to a minus 22. I'll divide both sides by 10. Now I'm dividing by a positive 10, so I'm not flipping my inequality sign anymore. Negative 22 over 10, I can actually reduce them by 2. And that'll give me a negative 11 over a 5. Okay. So what does my solution set look like? It looks like this. X, so that x is bigger than negative 11 over 5. Okay. Let me draw my number line. Okay. Remember, negative infinity here, positive infinity over there. Here's my number, negative 11 over 5. I'm going to fill that circle in. Again, if people always ask, why are you filling it in? Because I got that little equal to part right there, okay? Because of this little line underneath my inequality. And I'm going to the right because I'm looking for numbers that are bigger. And then my interval notation would look like this. Negative 11 fifths all the way to infinity and beyond, right? Very good. Okay, let's take a look at this next one here, which is a little bit of a word problem. And it says, if the revenue and cost of a certain product are given by, let's see, here's the revenue for X, here's the cost 2X plus 1,000. Where X is the number of units produced and sold, what production level does R at least equal C? Okay. So, revenue, just to give you an idea, I don't know, I'm going to make this up. Suppose I'm making, I don't know, I'm going to call it a widget. I'm making widgets, and I sell them for $4 each. So for every widget that I make, it costs me $4. Or that I sell, it costs me $4. To make those widgets, it costs me $2, but I had to spend $1,000 to rent the place where I make my widgets and all that kind of stuff, okay? So now we're trying to figure out what production does R at least equal C. So R is going to be at least equal to, so it'll be bigger than or equal to C. So R is going to be 4X, and that's going to be bigger than or equal to 2X plus 1,000. Okay. I'm going to minus my 2X on both sides. That's going to give me with 2X is bigger than or equal to 1,000. So when we divide both sides by 2, X has to be bigger than or equal to 500. Okay, so here's my solution set. Right? Here is my number line. Don't forget, negative infinity and infinity. The number I'm going to put on there is 500. That's the number that I care about. And it goes like this because it's bigger than or equal to. And then my interval notation is from 500 all the way to infinity, right? Very good. Alrighty. So these next parts are what we call three-part inequalities. The reason we call them three parts, y'all, is we have a left part, we have a middle part, and we have a right part. Okay? The objective, again, is to get the x by itself. So I want you to think about the middle piece. If I wanted to get the x by itself, the first thing we would say is, well, look, let's subtract 2. But if I do it there, I'm going to do it here, and I'm also going to do it here. Negative 9 is less than 3x, which is less than 3. And we said we're trying to get rid of our x. We're going to divide everything by 3. And that's going to leave me with negative 3 is less than x, which is less than 1. So my solution set is going to look like this. Okay. Now I'm going to draw my number line. Okay. I'm going to put my negative infinity and my positive infinity here. There's two numbers that I'm going to put on that number line. The first one is going to be negative 3. Second one's going to be 1. Okay. Now, when I get to this part, I want you to notice that my inequalities do not have the little lines. So those circles are going to stay open. And I want you to notice, in between the number negative 3 and the number 1, I have my letter x. That's the area that I'm actually going to shade. This is what I'm going to shade right here, okay? Since those circles are left open, we're not including the numbers. If we're not including the numbers, we're going to use parentheses, okay? So when those circles were filled in and we were using the numbers, we use brackets. Because these circles are open, I'm using parentheses. Alrighty. So let's take a look at this next one here. I'm going to go about it exactly the same way. I'm going to get rid of I want to get the x by itself in the middle. So I'm going to go minus 3, but I got to do it on all sides. So negative 9 is less than or equal to 6x. Less than or equal to 21 minus 3 is 18. Now I'm going to divide everything by a positive 6. Okay, so it's positive. I'm going to reduce that. Remember, because I'm dividing by a positive, my inequality signs are not going to change. Okay? So let's write our solution set. My solution set is x, and then I just remember copy and paste. Negative 3 halves less than or equal to x, less than or equal to 3. Okay? And I can draw my number line. Don't forget your negative infinity and your positive infinity. Okay, the two numbers we need to put are negative 3 halves and 3. Since these have the equal signs, those circles are filled in. And I shade everything in the middle because my x is in the middle. Okay? And now my interval notation or my interval form is going to look like this. Negative 3 halves, comma 3. Using brackets because, again, those circles are filled in, right? So again, in case you're wondering, this here, guys, is called interval. Sometimes we say form. Sometimes they say notation. The key word is they're both going to have interval. Okay. Alrighty. So let's take a look at the next one. First thing I noticed, look at those inequality signs. They're all flipped around, right? It's okay. I'm not going to worry about it right now. I'm going to do what we've done before. We're going to say, look, let's minus 3, minus 3, minus 3. Okay. 2 minus 3, negative 1 is bigger than negative 6x, which is bigger than minus 3 minus 3, minus 6. Okay. Now let's divide everything by a negative 6. So let's see, negative divided by negative, that's just positive 1/6. Because we're dividing by a negative, my inequality signs are now going to flip. Negative 6 divided by negative 6, positive 1. Okay. So let's write out the solution set. Remember, x, so that, copy and paste, right? 1/6 is, oops, let me get rid of that, here we go, is less than x, which is less than 1, okay? Let me draw my number line. Don't forget our negative infinity and our positive infinity. Let's put our 1/6 here and our 1 right there. Notice these do not have the lines underneath, so they stay open, okay? And because my x is in the middle, you got it, take it away. We're going to shade it in the middle. And then interval form, interval notation, 1/6 to 1 using parentheses, right? Parenthesis. Because those circles are filled in. All right. So I got another one right here. Again, don't worry about it. It's a fraction, right? It's okay. We're not scared of fractions. They're not like the kukui. All right. So let's multiply everything. We want to get rid of this 3. So we're going to multiply everything by 3. So that 3 is going to go there. It's going to go there. It's going to go there. Okay. So 3 times 1 I know is 3. Well, this 3 here, guys, and that 3 there are going to cancel. That's just going to leave me my x minus 3. 3 times -5, -15. Okay. Okay, now let's go ahead and add 3 here, add 3 here, add 3 here. This leaves me with a -12 less than or equal to x, which is less than or equal to 6. Okay. So let's write our solution set, x such that, remember, copy and paste, -12 less than or equal to x, less than or equal to 6. Let me draw my number line with my, negative infinity and my positive infinity. Let's put our two numbers, -12, +6. Should we fill in the circles? Yes, we should. Claro que yes. Remember, the x is in the middle, so I'm going to shade in the middle. And my interval form, or my interval notation, will be using brackets. Okie. All right. So the next part here about inequalities deals with these things called quadratic inequalities, okay? So the first thing we're actually going to do, we're going to write an equation. The only difference between an inequality and an equation is an equation has an equal sign. So I'm going to put equals 0, okay? So the nice thing about this problem, guys, because the number here is a 1, I can use my shortcut, right? So remember, I'm still going to multiply those two numbers. What's 1 times 10? Oh, it's 10. What two numbers multiplied at 10 but will add up to a -7? How about if we use a -2 and a -5? Okay. So I'm going to go x minus 2, x minus 5 equals 0. Okay. And when I set each part equal to 0, I'm going to get x equals 2, and I'm going to get x equals 5. Okay. Now, what we're going to do is we're going to make a little chart here. Okay. And right here, I'm going to put the number -2 and, I'm sorry, not -2, but +2, +2, and +5. Okay. So, I'm going to show you how we're going to do this next part. I'm going to need to pick a number that's going to be smaller than 2. Anything smaller than 2. I could pick 1. I could pick -8. Tell you what. Why don't we pick 0? Okay. I need to pick a number somewhere between the numbers 2 and 5. Oh, I don't know. What about 4? And I need to pick a number bigger than 5. Oh, I don't know. What about 8? Okay. Now, what I'm going to do here, guys, I'm going to look for, I'm going to be looking at the sign of my number. Okay. What I mean by the sign is, I'm going to come back and I'm going to take this number 0 and I'm going to plug it into the factored form. Okay. So think about it this way. 0 minus 2 is the number -2. 0 minus 5 is the number -5. All I want to ask you is, would this number here be positive or would this number be negative when I multiply them? Well, we know a negative times a negative is a positive, right? Okay. Now I'm going to do the same thing. Excuse me. I'm going to plug in the number 4. So I'm going to come back to this thing right here. So I know 4 minus 2, I know is 2. 4 minus 5 is negative 1. Would this number be positive or would this number be negative? 2 times negative 1, that would be a negative, right? Okay. Now I'm going to do it again. I'm going to take this number 8 and I'm going to plug it back into this expression right here. Okay. So if you want to know what I'm doing this. 8 minus 2, 8 minus 5. What's 8 minus 2? That's 6. What's 8 minus 5? That's 3. Would that number be positive or negative? Excuse me, that would be positive, right? Okay, so now here was our, think about it this way, this is my number line, okay? All right, here's my negative infinity, here's my positive infinity, okay? I'm going to put a circle around the 2 and a circle around the 5, and I'm not filling them in because I want you to notice I didn't have the little equal to business, right? Okay, I want you to think about, look at this piece right here, greater than 0. So I'm going to do this a little bit on the side because I want you to think about the number line for a minute, okay? So here's my number line. Remember, this is my negative infinity, this is my positive infinity, here's 0. Numbers that are bigger than 0, aren't those numbers positive? And numbers that are less than 0, aren't those numbers negative? They are, right? So positive, greater than 0 means positive, less than 0 means negative, okay? When I come back here, if we look at this piece right here, we want to know when it's greater than 0, which means positive. Well, where was it positive? It was positive here. Anytime we picked any number that was smaller than 2, we came up with a positive answer. So I'm looking at the interval starting from here to here, from negative infinity to the number 2, okay? When else was it positive? Anytime we picked a number bigger than 5. So from 5 all the way to infinity, union, okay? So what my number line looks like, I know it's kind of messy, but if I were to think about taking this number line right here and drawing it again, what my number line would have looked like was here was 2, here was 5, those circles stayed open, here was my negative infinity, here was my positive infinity, and what we shaded was this. This little U here, guys, is something we call the union. And it just means we're taking those two pieces that are sort of disconnected, right? Because we have a part in the middle that we didn't shade, and we're putting them together. Okay. So look, we're going to do another problem similar to make sure that we understand the idea. Okay. So the first thing I'm going to do is I'm going to distribute that x. That's going to give me an x squared plus 1x. And I'm going to move that 12 over to give me a minus 12 as less than 0. Okay. Now, I'm going to go ahead and start to write this out as an equation, meaning I'm going to put an equal sign. Okay? And notice again, the number in front of my x squared is a 1, so I should be able to factor this relatively easily. I'm looking for two numbers that multiply to a negative 12 but add up to a positive 1. Couldn't we use a minus 3 and a positive 4? So now when I set this up, x minus 3 and x plus 4 is equal to 0, I'm going to end up with two answers. One is x equals 3, one is x equals negative 4. Now, I'm going to draw my number line here, okay? Here's my negative infinity, here's my positive infinity. The two numbers that I'm going to put on my number line are, I'm going to first put negative 4 and then 3 because that's where they would fall on my number line, okay? Now, we're going to pick some what we call test numbers. I want a number that's smaller than negative 4. I don't know, why don't we try negative 5? I want a number somewhere between negative 4 and 3. I'm going to tell you right now, 0 is a real easy number always to plug in, okay? And I need a number bigger than 3. Let's try 4, okay? Now, guys, if you trust me on this, it's a lot of times it's easier to plug my numbers into the factored form. Okay. So we're going to plug this into the factored form, and I'm going to walk you through the entire process. So look, I'm going to go -5 minus 3, -5 plus 4. So -5 minus 3 is a -8. -5 plus 4 is a -1. A negative times a negative, that would give me a positive number. Okay. Now, I'm going to do it again. I'm going to plug in 0 this time. So I'm going to come back to this part right here. 0 minus 3, 0 plus 4, -3 times a positive 4. That number is going to be negative, right? Okay. And then we're going to do the same thing. We're going to plug in the number 4. So let me move this over un poquito. And I'm going to plug in my number 4. So I'm going to have 4 minus 3, 4 plus 4. That's going to be 1 times 8. That's going to be a positive number. Okay. All right. Now you might say, okay, what is it that I'm trying to find? Well, we're going to come back here. Do you see what that says? That says less than 0. Less than 0 means I'm looking for when is this thing going to be negative. Well, hey, look, it was negative anytime we chose a number between -4 and 3. Okay, so my graph is just going to be this right here. Those circles are going to stay open because I don't have the equal to. In an interval notation, I'm looking for the numbers between -4 and +3. Okay. Now, guys, the one thing I want to mention here, I just picked these numbers because they were numbers that were either smaller than -4, a number between between -4 and 3, or a number bigger than 3. Could I have picked 1 here? Yes. Any number I would have picked in this range would have worked. Okay. And I could have picked -8 instead of -5. I still would have gotten a positive answer there. Okay. So the numbers that you choose are not necessarily important. They just have to be numbers that are in that interval. Okay. So look, let's try this next one. We'll go about it the same way. First thing I'm going to do, I'm going to move that 16 over. X squared minus 16 greater than 0. Then I'm going to write the equation, okay, equals. I can factor this using my difference of squares formula. Okay. And the two answers we get when we set them both equal to 0 are one of them is +4, one of them is -4. So again, look, let's do this. We're going to go slow. -∞, infinity. Okay. -4 and 4. Okay. And I'm going to pick test numbers now. So let's pick a number smaller than -4, -5. Something between -4 and +4 is 0. Something bigger than 4 is 5. Okay. Again, if you trust me, it's always easier to plug it into the factored form. So look, -5 minus 4, -5 plus 4. This is -9. This is -1. This is going to be positive. Okay. When we plug in 0, 0 minus 4, 0 plus 4, -4 times +4, this is going to be negative. Okay. And now we're going to plug in 5. 5 minus 4, 5 plus 4. This is 1 times 9. This is positive. Okay. Now, we're going to figure out what was it that we were looking for. We wanted to know when it was greater than 0. Greater than 0 means we're looking for positive. So look, here's my graph right here. Remember, that circle is going to stay open. And it's positive over here as well. Okay. So using interval notation, I'm going to start at -∞ to -5. Then we stop. We jump over again, starting at 5 to infinity. And because those pieces are separated, we use the little u for our union.